In a previous video on creating an aviation-style altimeter for the Android phone using its USB port, I mentioned a Bluetooth version, pictured here, that I assembled as a prototype. It worked better than expected, but because I found the USB version more compact, I never bothered to order a professionally made PCB until now. After generating the required Gerber files and ordering a professionally made PCB, it is now possible to easily assemble the Bluetooth version using the custom PCB. Displayed here are all the parts needed to assemble the Bluetooth version of the Aviation-style altimeter for the Android phone. At the end of this video is a list of materials with part numbers and costs. In the previous video, I recommended the USB version for the Android phone over the Bluetooth version because of the higher cost. But you may want to consider the Bluetooth version for the Android phone despite the higher cost of approximately $40 compared to $20 for the USB version. Here is how I assembled the Bluetooth version. The first step was to solder the slide switch directly to the circuit board, followed by the following female PCB headers: 4 2-pin headers, 1 3-pin header, 2 4-pin headers, and 1 6-pin header. The purpose of the headers is to hold the 3.3 volt Arduino Pro Mini, the 5 volt voltage regulator, the BME 280 pressure sensor, and the Bluetooth transceiver. That way, none of these critical parts are soldered directly to the board and can be easily replaced if needed. The 3-pin header will hold the 5 volt voltage regulator, the leftmost 4-pin header will hold the BME 280 sensor, and the 6-pin header will hold the Bluetooth transceiver. The remaining headers will hold the Pro Mini. Note that only the 3 headers at the bottom of the board are actually part of the circuit. The remaining 2-pin headers, labeled J2 and J3, are merely there to hold the Pro Mini in place and keep it level. There is no need to drill holes for the remaining 18 unused pins of the Pro Mini. The second step was to solder the 9-volt battery holder. Make certain that the slide switch is moved to the off position by sliding it away from the center of the PCB. Only move the slide switch to the on position by sliding it toward the center of the PCB after all components have been installed. This will prevent the PCB from being powered until after all the components have been installed. The only remaining steps are now to prepare and insert the components into the appropriate headers. Note that I have labeled the on-off positions of the slide switch and some of the pin positions of the other components to make it clear the orientation of the components when they are inserted. The third step was to solder the minimal number of male header pins to the Pro Mini and then insert the Pro Mini into the female headers on the PCB. The minimum number to solder consists of the 90-degree bend 6-pin male header needed to program the Pro Mini, a 4-pin male header for pins raw, ground, reset, and ACC, a 2-pin male header for pins A4 and A5, and a 2-pin header for pins TXO and RXO. At the upper end of the Pro Mini, also solder a 2-pin male header to pins 7 and 8, and a 2-pin male header to pins 11 and 12. Note that the upper 2 pairs of male pins are soldered in the next to the last row. This was done to save space and because those pins are there only to hold the Pro Mini and are not used in the circuit. Note also that the Pro Mini is not programmed by a standard USB port. It is instead programmed through a serial connection by a cable connected to the 6 male pins exposed on the left side of the Pro Mini as shown here. Note that this is the best time to install the program because the serial ports of the Pro Mini are not being used by any other device, as will later be the case when the Bluetooth transceiver is installed. There is a link in the description of this video to my GitHub page where you can download the program and then use the Arduino IDE to transfer it to the Pro Mini using a special serial to USB cable. Pictured here is the serial to USB cable that I used. You will need a serial to USB cable that is set for 3.3 volts in order to transfer the program to the Pro Mini from IDE running on your computer. There is a switch on the converter board that can be set to either 5-volt logic or 3.3 volt logic. Since the Pro Mini is using 3.3 volt logic, the switch is set to 3.3 volts as shown here. Once the program has been transferred to the Pro Mini, the assembly process can resume. The fourth step was to solder a 4-pin male header to the BME 280 sensor and then insert the BME 280 into the female header on the PCB as shown. Care must be taken to orient the BME 280 correctly so that the SDA pin on the BME 280 matches the SDA location on the female header as identified and shown in the previous slide. The fifth step was to insert the 3-pin voltage regulator into the female header on the PCB as shown here. Note the orientation of the heatsink. The sixth step was to install the 9-volt battery in the battery holder, then connect 3 6-pin female headers to the Bluetooth transceiver, and bend the headers in such a way as to make a 90-degree bend. This is done so that when the Bluetooth transceiver is plugged into the PCB, it will be oriented parallel to the PCB and will rise above the other components. The last step is to insert the Bluetooth transceiver with its 90-degree bend into the female header on the PCB. Note the orientation of the Bluetooth module with the antenna facing up. All that is needed to test the device is to switch it on by sliding the on-off switch toward the center of the board, place the assembly into its protective carrying case, and then pair the Bluetooth device with the Android phone before launching the vector display app on the phone. The default baud rate of the Bluetooth transceiver is 9600 baud. That can be changed by following the instructions located in the comments to the program on my GitHub page. Additional information on installing the vector display app, using the Altimeter program, and Gerber files for generating the PCB can be found on my GitHub page. Here is the complete list of materials and cost of each item, not including the 9-volt battery. Thanks for watching, and please like and subscribe.